Hello everyone, I welcome you all to this lecture. In this lecture, I am going to discuss SR Latch. With the help of NOR gate, I am going to construct SR Latch. So SR Latch, there are two terminals in that. Before going to the detail on SR, what is latch actually? The verbal meaning of latch is when I'm searching on Google, it is displaying latch means kundi. Okay, and the image it is also displaying on Google. So you can understand what is the meaning of latch. Latch is a kind of circuit. It works like a lock. So when we put a lock or latch on the door, the inside thing will not be allowed to move outside, right? The state will be preserved. So similarly, in the circuit, when a circuit is generating some output, when we apply a latch, the latch will help us to hold the output of the circuit. That's why the name given as latch, right? So let's discuss SR latch with the help of NOR in detail. So I'm going to construct the SR latch with the help of NOR gate. So you are aware about, let's say, I'll consider, okay, I can make a small circuit. So let's say there's a NOR gate like this. There's another NOR gate. So this is two input NOR gate. I can copy this and like this. Okay. So this is another two input NOR gate. Now let's have a connection. So this output, because it is a sequential circuit, I'm connecting this output to, let's say, this input of this like this, and I'm connecting this input to this output here like this. Okay, and these terminals we will make one as set pin, another will be treated as reset pin. So this is the diagram you can consider. Now these pins will generate state Q and Q complement, right? So this is, let's say, Q and this is Q complement. Now we need to decide which pin will act as set pin and which pin will work as a reset. So S is for set and R is for reset. Okay. So let's say set, the behavior of set pin is once the S or set pin will be high, this Q state will become 1. And in case reset pin is high, this Q will be generated as 0. So in order to set this set or reset pin, let's try to understand the behavior of NOR. So if I draw the truth table for NOR, let's say this is NOR, the behavior of NOR is like this. Okay. Now this is input A, this is input B, and this is, let's say, A or B bar. This is the Boolean function of NOR gate, right? So that will, there are 4 combinations: 0 0, 0 1, 1 0, and 1 1 we have. And 0 0, for 0 0 NOR generates 1, and for remaining cases it will generate 0. So there is a point which we should keep in mind. If either of the input in case of NOR gate is high, NOR gate will generate output as low. If both the inputs are low, then only it will generate output as high. Okay, so if I make this pin as set pin means as if it will become 1, then Q will become 0. So this pin cannot act as set pin, it should be a reset pin. So I'm making it R, and then this pin should act as set pin. I hope you're getting it right. So this is R and this is S, this is Q and Q bar. Now let's analyze the different thing when we pass different input, how this circuit will behave and how it will work as a memory element. So let's consider one case. So let's say we are having case 1 here. So let's say the very first case in which we consider, let's say the S pin, set pin is high and reset pin is low. So when set pin is high, that means I'm giving this value as 1 and this value as 0. So when this is 1, there's a guarantee that this NOR gate will generate 0. So this will generate 0 because any of the input when we give as 1, the output will be definitely 0. So this Q bar will generate 0 and this 0 will propagate here and reflect here. Now, so this NOR gate will have both the inputs as 0, then the Q definitely will have value 1, right? So this is the saturated state Q and Q bar when we are setting S as high and R as low, right? So in this case, we are getting, writing here, Q we are getting as 1 and Q bar obviously because it is the complement of it, it will be 0. Now in case we remove, the meaning of latch is once the latch is applied, the state must be preserved. So whatever you do here, so let's say if we remove this voltage or this input, so if I'm making both the inputs as low, I'm just removing these inputs. So if I release these input, that means this pin is 0 and this pin is also 0. Now in case both the pins are 0, let's try to analyze what will be the behavior of Q and Q bar. So I'm considering that I'm just cancelling it out. This I'm not treating as 0, 1. Now analyze it. So I'm starting analysis with Q. I assume that Q is given as 1. So if this is given as 1, this will reflect here as 1. If this is 1 and this is 0, we will definitely going to get 0 here. So this is 0. So in case previous state was 0, new state will also, it will generate as 0. Now if this is 0, this 0 will reflect here and this 0 0 will going to give us 1. So new state is also 1 here. Q will be 1 and Q bar will be 0. Previously also it was 1 and 0 only. So that means state is preserved. Now in case you do not start the analysis with Q and you are trying to start with Q bar, so let's start the analysis. The same thing you can analyze from Q bar also. So you assume that Q bar is 0, both R and S are 0. This 0 will propagate here and this 0 0 will give you 1. So earlier it was 1, now the new state is also 1. Similarly previous state was 0 and this 1 will reflect here, right? So this 1 0 will give you 0 only, so the new state is also 0. So in any of the scenario, in case you are having R and S both are 0, then the previously generated state is preserved. And in that case, I consider, let's say this is case 0 or case 2, in which I am setting S as 0 and R is also 0. This makes this particular circuit as memory element. So memory element I have talked in the previous lecture. Okay, so this circuit is working as memory element, right? Now let's analyze the another case in which I'm just removing all this. Okay. Now let's say another case in which we are considering S as 0 and R as 1. R means reset is high. So if reset is high, this pin is 1 and S as 0. So if this is 1, Q is going to be 0 definitely, because this NOR is getting 1 input as high. In that case, it will generate low output. And this 0 will propagate here, and then both the 0 will give us 1. So Q bar is going to be 1. So in that case, Q is 0 and Q bar is going to be 1. There's not a problem. Both are managing the complement. So that's fine. Now in this case also, if you release these SNR and you make both these inputs as 0, let's analyze whether it will be able to preserve the 0 1 state or not. So let me remove this, and I'm making this R as 0. So when both are 0, I start analyzing the circuit. So I just remove it, and you start analyzing the circuit from Q. So let's say Q is 0 and this 0 will propagate here. So this 0 will come here. Now this NOR gate will have both the zeros. So when both the zeros are there, you will get 1. When both the inputs are low, NOR gate generates high. So previously it was 1 and now it is generating 1, right? This one will propagate here, and this NOR gate will have one input as low, one input as high, and it will generate 0, because when any one of the input is 1, then the output is 0. So it is not 1, it is 0, right? So this is generating 0. Earlier it was 0, now it is also 0. Earlier it was 1, now it is also 1. The same analysis you can start with Q bar also, you will get the same thing. So that means in this scenario, if you are setting S as 0 and R as 0, then the same state will be preserved. Q will be 0 and Q bar will be preserved as 1, right? So that means this circuit is working as a memory element when S and R both are 0. Now let's discuss the fourth scenario. So let me wipe all these. Okay. Now I'm having, let's say, reset as high, and let's say set pin is also high. So when we are having both pin as high, let's try to understand what will happen. So according to the truth table of NOR, when either of the input will become high, output will be low, 0. And similarly, this will also become 0. Now this is the situation which is not very much desirable. It is undesirable because this is representing Q and this is representing Q bar. So there has to be a complemented value. So if it is 0, it has to be 1. If it is 1, it has to be 0, but it is violating this. So the fourth scenario, which I am writing, let's say the fourth one, where you are considering S as 1 and R as 1, it is restricted. So this S1 R1 is restricted when the SR latch you are constructing with the help of NOR gate, right? So I hope you are able to understand the behavior of SR latch. In next lecture, we will discuss the SR latch which we construct with the help of NAND gate. So I'm closing this. Thank you for connecting.